Hello and welcome to this 8-minute video which looks at complex numbers in polar form, multiplying, dividing and expanding using the Moivre theorem. Okay, if z is equal to 2 plus 2 root 3i, w is root 3 plus I, we want to find zw and z divided by w in polar and Cartesian form. Firstly, this requires us to change each of these Cartesian form complex numbers, z and w, into polar form. So let's draw a little picture first of z. That's 2 plus 2 root 3i. And it's in the first quadrant. And this can be represented by this red line. And we want to work out what is the modulus and the argument of this complex number. Because in polar form we need the modulus and argument. So the modulus is given the square root of a squared plus b squared. So in this case that's the square root of 2 squared plus 2 root 3 to be squared. Now you could take out the calculator or work this out the long way. And we get 4 plus 12, and that's the square root of 16, which is 4. So that's the modulus of z. Now to work out the argument, if we complete this triangle here, we see that the opposite is 2 root 3 and the adjacent is 2. So tan inverse of theta is 2 root 3 over 2. This is the same as root 3. This is one we might recognize, that tan inverse of root 3 is 60 degrees. We can use a calculator if not. And 60 degrees is pi over 3 in radians. Probably a preference for using radians here. So z is equal to the modulus 4 into cos times the argument plus I sine the argument. A short way of writing this is CIS times the argument. And using this in shorthand saves you a lot of writing in the exam. Okay, let's consider W then in the question. So W in Cartesian form is root 3 plus I, and we want to put this in polar form. So firstly we need to figure out what is the modulus and what is the argument. So we draw a quick sketch of what this might look like. Again, it's in the first quadrant, so we mark off root 3 on the x-axis and I on the imaginary y-axis, and we just sketch what this little triangle to represent this, and we want to know what is r, the modulus, and theta, the argument of this complex number. So r is equal to the square root of root 3 to be squared plus 1 squared. And this works out as square root of 4, which is 2. So the modulus is 2. And working out theta, the argument, we consider the triangle. And here we have tan inverse opposite over adjacent 1 over root 3. Again, it's one we might recognize, but using the calculator, if not, we see this is 30 degrees or pi over 6. So writing out in polar form, we get W is 2 CIS pi over 6. So now we have Z and W in polar form. Now we want to multiply Z by W. And this is quite easy to do in polar form because we just multiply 4 by 2 and we get 8 by CIS, and we add the two arguments. So we multiply the moduli and add the arguments. That's how we multiply in polar form. And this gives us 8 CIS pi over 2. That's the answer. So we have it in polar form, but it also, we want the answer in Cartesian form. Now we don't have to multiply them out again in the Cartesian way. What we can do is just take out the calculator and work out the value of cos pi over 2 and sine pi over 2, and just evaluate this. And when we look at this, pi over 2 is 90 degrees, and we know that cos of 90 degrees is 0 and sine of 90 degrees is 1. So we're left with 8 times 0 plus 8 times I. So the answer is just 8i, and that's in Cartesian form. And now the last part of the question, we want to divide Z by W. So we have 4 CIS pi over 3 divided by 2 CIS pi over 6. The rule for dividing in polar form is we divide the moduli and subtract the arguments. This gives us 4 divided by 2, which is 2 CIS, and 1/3 of pi minus 1/6 of pi gives us pi over 6. That's straightforward to do that as well. Again, to convert this into Cartesian form, rather than multiplying or dividing out again in Cartesian form, it's easier just to take out the calculator and work out the value of cos pi over 6 and the value of sine pi over 6. If you didn't have a calculator, we could consider this triangle because we might recognize 30 degrees. And we see the cos of 30 degrees is root 3 over 2. So it's 2 times root 3 over 2. Plus I sine 30 degrees and sine 30 degrees is 1 over 2. And we see here that the 2's will cancel out here. And so the answer is just root 3 plus 1i. And that's the answer in Cartesian form. Okay, the last part of the question. We know that z divided by w is 2 CIS pi over 6. And we want to evaluate this to the power of 14. And how do we do this? Well, this is an application of the Moivre's theorem. His theorem says that z to the power of n in polar form is r to the power of n times CIS n times the argument. So it follows from this that z divided by w to the power of 14 is equal to 2 to the power of 14 CIS 14 times pi over 6. So we want to evaluate 2 to the power of 14 times cos, and 14 pi over 6 is 7 pi over 3, plus I sine 7 pi over 3. Using the calculator, 2 to the power of 14 is 16384. Cos 7 pi over 3 is a half. Sine 7 pi over 3 is root 3 over 2. So that gives our answer as 8192 plus 8192 root 3i. Thank you for watching this video. I hope you found it useful.